Good morning, students. Welcome to the physics class. Today we are going to discuss about one of the interesting chapter, a term as in what here, the moving charges, and also what is it, magnetism. Before we are going to study about the moving charges and also the magnetism, we need to study about this. What is the meaning of this? Let us go for the introduction to this particular chapter. You already know that the meaning of charge. Here we have a charge. Let us consider that Q is a charge here. Q is a charge. This particular charge is under what here? The rest. When the charges are in the rest, the study of this particular charge under rest is termed as what here? Electrostatics. So we can call it as what here? The study of this charge under the what here? The rest. We can call it as what here? Electrostatics. Okay, electrostatics. Statics. It means that it is under what here? The static condition. It is not at all moving. The charges are not at all in moving. Now let us pass on to when the charges are in what here? The motion. When the charges are in motion, this is the Q is the charge here. Okay. This particular charge is under what here? The motion. The study of the charges under the motion is termed as in what here? The current electricity. Okay, this particular chapter is termed as in what here? The current electricity. Current electricity. This produces heat. Now this particular charge, the moving charge, is there in the what here? The conductor. The conductor is carrying this charge. Okay, this is the conductor which carries this, the Q is a charge here. Around this particular conductor, whenever the charges are in motion, this is the current, current electricity we had already studied. When these charges under the motion, we will get a what here? The current, that is nothing but a what here? The I. When a conductor is carrying this particular charge, or we can call it as a what here? The current. Around that particular conductor, what is present? There must be an what here? The attraction. There must be an what here? Maybe a repulsion is there. It means that there is some kind of what here? Around this conductor. There must be a presence of what here? Magnetic property. It will attract. So this particular thing, that is nothing but what here? The electricity, there is a current electricity, and also there is an what here? The magnetic property or a magnetism, or what here in this particular chapter is unified. So this particular unification of what and what here? This current electricity, and also what here? The magnetic property of this. It is termed as in what here? The electromagnetism, we will say. So unification of these two, combining of these two, unification of these two is termed as in what here? Electromagnetism. There is one word is termed as in what here? Electromagnetism. Magnetism. So this is what we are going to study under the what here? The moving charges, and also what is that? Magnetism. So here how it is related and how it is the charges, when moving charges is there, means how there is a magnetic field is there around that particular conductor. We can able to what here? The study with the help of one simple experiment, okay, conducted by the what here? Christian Hans Oersted. So it is the famous as what here? Oersted experiment. Okay. Let us consider the first and the foremost thing is considered as what here? Oersted experiment. O-E-R-S-T-E-D. Oersted experiment. What is this Oersted experiment? This is a very simple experiment. Okay, here we have one the conductor. Okay, let us say here we have the conductor. This particular conductor is a carries of what here? Current. So here I can able to mention A. This side I will mention as what here? The B. It will what connected to one. So here is a positive and this side is what here? The negative, and then it is connected to water. So here is a one simple. So the key I can able to mention. Okay, here we have this side is the positive and this side is the negative. AB is considered as what? Yeah, the conductor. Beside this conductor, just keep a one magnetic needle. You know magnet. What is the meaning of magnet? A magnet is a substance which attracts the what? Yeah. So magnetic substances such as what? Yeah, iron, nickel, cobalt, etc. like that. So there are different types of magnets out there. You know that the magnet is so like this. It is termed as what? Yeah, the Bohr magnet. Okay, the Bohr magnet. The north pole is this side and the south pole is this side. And there is a horseshoe magnet. So you know that the horseshoe magnet is like this. So this is a horseshoe magnet. Okay. So this pointer is always mentioned the north side. And also there is a magnetic needle. You know the magnetic needle is represented like this. So in this manner. Okay, this is the magnetic needle. Okay. So one side is blocked like this. So it is always mentioned as what here? The north side. And there is a magnetic compass. So the magnetic compass. So inside this there is a magnetic needle which is present. So these are all the types of magnets we have. So let us consider the magnetic needle. I want a magnetic needle beside this water. This conductor. So just keep one magnetic needle above this one. Above this one means here. Okay, just here. Just we can keep above here like this. So magnetic needle here. Okay, needle in this one. Just I will mention as this one. So this is the magnetic needle. So this will shows what here? North. Now what you have to do is just only one click it. Okay, it means that just you on this one. This is in this one. Okay, tap. Once you just tap it, then what happens to the current? The current is the flows in this direction. Current starts flowing the positive, and then it comes here and goes to the negative. So tap key here. Then what you will going to observe here is this magnetic needle is the deflects at the one side. When suddenly it happens means, so what happens here? So it will what happens? Deflects in this particular direction. So it will shows in this way. So this not the direction. Now conduct the same experiment in a different manner. Change this polarity of this. So the polarity means the positive is becomes a negative. Negative becomes a what here? The positive. Then you just change this one. So just can just change this one as negative. This one as what here? The positive. So I will show in the dotted lines. Just do in this one. I will change this polarity like this. This becomes a negative. This becomes a positive. Then what happens? So the magnetic needle is the turns in an opposite direction. So the north direction comes suddenly like this. So I will show this is also in a what here? The dotted lines. So it is in opposite direction. Then it conduct the same experiment in a different way. In a different way, it means that increase this one, increase the what here? The current. As you go on increasing this particular current, what happens? There is a more and more what happens? Deflection in source. There is a more and more deflection in source. If you change the polarity, there is a what here? In opposite direction it will shows. If you go on increasing this particular current, it will show what here? More and more what here? The deflection. And also another one, it will change this one, this conductor. The length of conductor is go on increases. Then also there is a what here? It will show a change. It will increases the water, the deflection. It means that it shows that a conductor that carrying a current. Conductor is carrying a what here? The current. Around that conductor, what is present? What is present? There is a presence of what here? The magnetic field around it. Okay. The conductor carrying a current. Conductor carrying a current. Current. Around a conductor. Around conductor. Conductor. The reason what is present there? The reason magnetic field. There is a presence of what here? The magnetic field. I will always represent that particular thing as B. So this leads to what here? The unification of what and what here? So there's the electricity or current with the what here? The magnetism. So that is why we can call it as an electromagnetism. So this is the very simple experiment that is called Oersted experiment. This leads to the conductor carrying a current around that particular conductor. There must be a presence of what here? The magnetic field. It means that the charges are in what here? Underwater? The motion. When the charges is under the motion like this, so it leads to what here? The current. Around that conductor, there is a presence of what here? The magnetic field around it. Now this particular field, I want to know about that. What is the direction of this magnetic field? Okay. In 9th standard, you might have study about this. What is the direction of the magnetic field? How to find out the direction of the magnetic field and how to find out the direction of the water, the current. You know the well-known the law is termed as what here? The right hand thumb rule. Thumb rule. This is well known for you in 9th standard itself. What does this particular law says? Imagine you are holding a conductor in your right hand. So here we have I'm using a scale itself. Okay, this is the conductor. This conductor is carrying a current. Okay, this is in this direction. This is the direction of the current flowing. So thumb is outward. Thumb is, I'm showing this particular thumb as an outward, like this. And all other fingers, I'm holding like this. Okay. This thumb is shows what the direction of the current. The thumb shows what is the direction of the current, and all other fingers are shows the what is direction of the water, the magnetic field. So you just observe. So it is like this, and it moves in this manner, moves in this way. So the magnetic field around is like this, in this way. Just imagine it. It is. I am holding in the opposite direction like this. The current is moving in the downwards. Then the magnetic field is in this way. Just you see. Okay. This is the clockwise. And if you say in this manner, this is called as an what here? Anti-clockwise direction. This is about what here? right hand water, the thumb rule. So this leads to, this particular Oersted experiments leads to what? So electro, the magnetism, and that particular unification is termed as a moving charges and also what you can say magnetism. Okay. Thank you for watching this video. Thank you.